Hi, I'm a tutor in Uplatz. Today we are going to discuss about MATLAB Coding Guidelines Part 6. Make error messages informative when possible. Supplement the MATLAB warning or error message with specific information that will help the user understand the issue and what to do about it. Write prospective error messages. It is more useful to tell a user what to do about an error than to simply state that an error has occurred. Replace error, argument error with error make beta between 0 and 1. Use message IDs with errors and warnings. Message IDs provide additional useful information and allow selective disabling. Replace error make beta between 0 and 1 with error 4 parameter check make beta between 0 and 1. Use exceptions. An exception object supports more flexibility in dealing with an error condition than a simple error function. Provide an exception argument for the catch command in a try-catch construct that works with errors. Support error returns. The best practice is to use exception handling for function errors. This makes it easier to handle the error at the most appropriate level. If you choose not to use exceptions, you can use function error return code. If the return code is numerical, then it should be integer. By convention, a number 1 or a positive integer should be used for the absence of an error. 0 or negative number should be used for an error condition. It's a good practice to return a message on an error. Support written errors. Do not use the implicit error return of a function in if or switch constructs. This practice is more difficult to understand and it removes the opportunity to grab the error messages. Replace if who will lesson or deal with error and with error code error message Boolean. If error code deal with the error end. Use appropriate assertion. In MATLAB, the assert function is closely related to error. It can act as a replacement for the basic if error sequence. For example, assert x less than or equal to 0 is equal to but greater than 0, error end. Use appropriate assertions. Assertion can also replace try-catch constructs. A series of assert statements can be more compact than a series of if, error, or try-catch constructs. For some developers, assertion is used only for an impossible condition, whereas error is used for an unlikely and problematic condition. In others, use assertion to uncover programming defects and error to catch data-related problems. Learn to use sprintf. MATLAB provides a function integer to string to produce a number with no decimal places and number to string to produce a number with up to 2 decimal places. You can achieve more flexibility in the number of decimal places with sprintf or printf assign sprintf percentage 5.2 value. Learn to use text. You can include text markup in character strings to include special characters and symbols in the resulting strings. This capability is especially useful to analyze labels and text entries for the graphs. Write at least one test for every function or method. This practice will improve the quality of the initial version of the function and the reliability of changed versions. Thinking through and writing the test code can help better define the functionality and arguments of the function. The test should verify the response to the defined number and types of argument. It should also test the envelope conditions. Update the test when you change the production code. Be sure that your test suite covers any change in behavior. In general, you should add rather than delete tests. Write small tests. thorough testing requires a set of tests. You will find it easier to evaluate the output of a small test than a long, complicated one and trace any test failure back to the relevant code. Do not write tests within production code files. Writing a test in its own file is better than using an embedded test subfunction. The test is more likely to be complete, and the production code is less likely to depend on the test code. It's also offered to use a test subfunction for automated testing. Write uncoupled tests. Write the test code so that the results do not depend on the order of the testing. Test code will change, and interdependent tests will cause even more debugging. In general, each section of test code should include its own setup, evaluation, and cleanup. Write tests with Boolean outputs. You can best automate testing, especially when you running multiple tests by writing tests to have Boolean outputs. Typically, the output value is true if everything works, or false when at least one case fails. Code processes the test if any valid input produces a correct output, and if any invalid input is detected and code with. Tests for expected exceptions. Your production code may include exception statements. Your test code should trigger the exception, catch the exception, and make sure it is the expected one. An example would be a function that generates an exception for invalid input. The test code would call the function with an invalid input variable. The function fails this if the exception is not generated. Write tests you can automate. So, support test automation by using a program or framework that runs the test. In general, write one test function or a class that includes all unit tests for each production function or class unless it becomes too long. If it is too long, then break it up by type of test, feature, or method. Consider writing unit tests that do not stop or error. Getting results from multiple unit tests can help determine what went wrong. Thorough testing may require writing tests that go beyond obvious user stories or stated requirements. Patterns can help define these important test-specific tests. Your test patterns may include looking for problems with binary data, such as extreme values and empty variables. Write tests can operate and support test automation by using a program or framework that runs a test. In general, write one test function or class that includes all unit tests for each production function or class unless it becomes too long. If it is too long, then break it up by the type of test, feature, or method. Consider writing unit tests that do not stop on error. Getting results from multiple unit tests can help when what went wrong. Thorough testing may require writing tests that go beyond obvious user stories or stated requirements. Patterns can help define these important but under-specific tests. But test patterns might include looking for problems with boundary data such as extreme values and empty variables. Use related names in the function and test code. Use the same or related variable names in both places, make it easier to scan the test and production code for variable document matching or naming issues. When calling the functions who alpha beta, use who alpha beta or who this alpha this beta. Identify test files by name. Use the word as test as a prefix in the test file name to support easy file organization. Using a distinctive name style for test functions and files make it easier to select test code for automation and to prevent production code for depending on test code. Using a test name that is closely related to a function name makes it easier to find appropriate test code. For example, use the name test underscore code definition code. Develop test patterns. In general, the test code should require less time to develop than the code to be tested. Yet, the test code is as difficult to write correctly as project code. strategy is to develop test code patterns. The patterns could, for example, produce interesting input or evaluate expected outputs. When the inputs are common to multiple tests, write setup codes to produce them. Thorough testing may require writing tests that go beyond obvious user stories or stated requirements. Patterns can help define this important but under-specified test. Your test patterns might include looking for problems with boundary data, such as extreme values and empty variables. Consider tests for external software. You may want to write tests for external software that interfaces with your own to be sure that you understand how it works. You can also run these tests when new versions of the external software are released to catch any problematic changes. Make use of MAT files. Consider storing pre-processed input data in a MAT file for multiple processing accesses. Organize data into arrays, structures, or objects with meaningful names. Organize the data so that access and computation are as ciphered as possible. MAT files have a big advantage over other file types in that they maintain the variable name associated with the data. Follow database conventions. Use standard database arrangements for the data arrays. In the usual database organization for a data label, each column is a field, parameter, or variable. Each row is a record, sample, or observation. Good database practices include selection criteria and having a good field for selection. Consistency names and types, sorting and having a good field for sorting, and input validation checking before storing. Follow the MATLAB convention for array orientation. Data array orientation. Put time series in columns of data arrays. This is the default orientation for most MATLAB functions. Similarly, arrange data that will be summarized and compared so that the summary is along columns and the comparison is along rows. For example, consider a data array of temperature by date for several cities. The data for each city would be a column, and the data for each date would be a row. For associated variables, the date would be in a column vector, and the city names would be in a row cell array. Organize general purpose M files and toolboxes. Develop general purpose programs in arrays of toolboxes to increase productivity. The library is particularly helpful for related functions such as statistics or time series analysis that are useful in more than one application domain. Write your toolboxes for sharing. Standards are higher for public toolboxes that you are share with others than for personal toolboxes for your own use. Improve the quality of your code by having others use and criticize it. A public toolbox should be usable by non-express and customizable and extensible by experts. Put the test files in a separate directory. In general, do not release test files in a production code toolbox directory. Putting the test files in their own directory makes the release separation easier. Use separate directories helps avoid any dependence on the production code of the test code. Consider writing demo files. Demo files provide the user with quick examples of the capabilities and uses of the functions in the toolbox. Demos often use graphical user interface, GUIs, or graphic space, and they allow the user to see results without extensive programming. Some users find it easier to learn how to work with a function or a class by studying examples rather than syntax descriptions. Demo files provide an opportunity to show extended examples that would not fit in the command-based documentation of the code module. The demo file directory is also a good place for published documentation files. Use a consistent toolbox folder organization. Toolboxes for methods follow very folder organizations. The most basic approach seems to be that a toolbox for audio processing would be in a directory named something like audio with subdirectories audio and audio GUI. The audio review subdirectory contains demo steps, data files, the data demo XML file, possibly private subdirectories, and HTML subdirectory for publishers. The demo XML file supports integration with the help system. The audio subdirectory contains the toolbox files and the content file and any import.xml file and possibly some private subdirectories. The info.xml support file supports integration with the help system. Naming the help file subdirectory the same as the toolbox directory or is confusing. It is better to use a different name such as functions, programs, or tools. Provide for integration with MATLAB. Add the toolbox location to the MATLAB path so that they are easy to use, and also add the function demo and GUI subdirectories to MATLAB path. Pay attention to the order directories on the path to avoid surprises caused by functions named shadow key. Provide a reference page for every public function. Use the publish feature to produce documentation function from its same file. Having the reference information source and the code in the same file makes it easier to keep it consistent. Make your HTML reference page look like the standard reference pages in the help browser. Integrate the reference pages with the help browser. Build a search database for the reference pages. Put an imported XML file that points to where reference pages in the toolbox function folder so that it's on the MATLAB path. Even simple functions when each search access through the help browser. Do not make your toolbox a subfolder of the MATLAB folder. MATLAB recommends that you do not make your toolbox a subfolder of the MATLAB folder. This will help avoid problems when you add to your MATLAB installation or install a new release. This also means that you put your toolbox reference on help folder under your toolbox folder rather than under the MATLAB help folder. Organize your project-specific files by project directory. In general, avoid using the default MATLAB directory for anything except temporary work. This directory may be lost and will be on the default path in the MATLAB product is graded. Organize your data directory for ease of access. Your data file will usually be written only once, but it may be read multiple times. Group data files and organize them in directories so that they are easy to find and read automatically. For projects with small amounts of data, you can continue to place data and MATLAB approach in a single directory. For example, the directory analyze_here may contain Boolean, action, wheel, and struct math. Organize your data directory for case of access. For projects with large amount of data, use programs and data subdirectories to simplify directory listing and use backup policies. For example, the directory analyze_here may contain subdirectory programs containing M-Lint and the subdirectory data containing wheel 101.1, wheel 102.1, struct 201.1, struct 202.1. For projects with very large amount of data, we use multiple data security in addition to using backup. The organization also supports simple automated data file access. For example, the directory analyze_here may contain the separated products subdirectory data containing plain 101 each containing wheel match, struct match. Accept change. Requirements are often incomplete and can change with little warning. Usage changes. Technical software, perhaps more than other types, will be used for new and different laws. Accept changes. You can plan for changes by writing code to a consistent style and maintaining a thorough SO. You can also adapt incomplete and changing requirements by providing early prototype to the users. Include appropriate flexibility. Too little flexibility in your code can lead to a lot of work in the future. Too much can lead to a lot of work now. Your experience will guide you toward the right amount of flexibility. Code that will be part of your toolbox or shared with others should typically be more flexible than code with a short lifetime and for your own use. The input parser object is a good example of flexible code. It is used by many people to work in many different functions. Input parser only does two things, but it is flexible enough to work with a variety of input argument. Yes. Use the right algorithm, scalability and cost performance come not so much from the core optimization as from design and selection of the right algorithm. Appropriate algorithms and even tested code are available for many tasks. Do not waste time coding the wrong algorithm. Program by contract. Design modules interfaces to pre and post conditions to support thoughtful development and application. When modifying code, try to extend it, maintain interfaces and functionality rather than making a change that can cause problems with other routines. Write for automation. Avoid keyboard input and pause commands when possible. Use a parameter guide instead. This approach is particularly important for automated test and data analysis. Make associated data easy to use. Carefully consider what data belong together based on what will be done with them. Often the organization of the data will indicate the best way to organize the code. Typically, data that go together should be placed in a structure or object. The structure can be better than an object if the object would be only a data container that has no behavior. Recompute when the data changes. When the input data changes, try to recompute all the results rather than doing a partial update. This practice will then reduce the inconsistency in different variable values. The data and the results are in a single object or a structure. Any method or function that changes this data should probably recompute the results. The code optimization for the last are never. Optimization for speed or memory usage tends to make code more cryptic and may not be needed. Also, defining the optimization technique, implementing it, and testing it all take development time. Consider coding standard. Coding standards specifically common elements for the code that make it easier to share and use code and easier to understand the ideas expressed in the code. They are programming rules that reduce the likelihood of introducing errors into the programs. They go beyond style guidelines to address topics such as use and behavior. Examples include specific variable names, input and format, and processing algorithms. Consider coding standards. Most coding standards can increase product reliability, code portability, case of maintenance, and usage lifetime. Increase programmer productivity through reducing the learning curve for your language. Increase team productivity by facilitating communication. Reduce development and support costs. Streamline code reviews. Increase the years with which certification is uptime. Develop in small steps. Build confidence in the code incrementally. It is more likely that you can write a few lines of code at a time without error that many lines. Finding the bug in a few lines of code is much easier than finding in a large number of lines. Automate as many development steps as you can. Change code in small steps and test it promptly, particularly in refactoring. Check code into version control and yearly and often. Develop in the editor. Write the code in the editor rather than command window. It will likely be better structured, have better style, and still be easy to execute incrementally during development. Version control, use of version control. Version control is the best way to manage and document code changes. It is helpful for solo development and almost essential for team development. Use a version control application that is appropriate for your development environment. MATLAB currently supports direct integration with only a few source control applications. You may need to find a third-party interface or a user manual process. Run test often. The test the production code that you write as you write it. This testing is the first instance of the code. It provides quick feedback on code quality and the effect of changes. Automate all testing as much as possible so that it is easy and quick to run. Code that is tested only in development environments may fail after release. Run all tests in a pre-release environment to be sure that the code in the release is complete, consistent, and run correctly in the target environment. Try the MATLAB Editor. The MATLAB Editor has many features that will help you apply these guidelines and write better code. It provides color syntax highlighting, selective code execution, automatic indentation, and parenthesis matching. The M-Lint feature helps improve code quality by providing prompt feedback on errors and questionable usage. The editor includes debugging features for efficient troubleshooting. In addition to selective code execution, the self feature also helps clarify blocks of code and support publishing. Try the MATLAB Editor. Most developers use the MATLAB Editor. If you prefer a different editor, use one that at least supports color coding, automated indexing, selective simplification, and search and replace. You will probably go with the code in MATLAB Editor at some point to use its additional features. Check your editor performance so that the code looks the same in both editors. Use Smart Indent. The editor automatically provides indentation for groups and selection context while you type. If you write code statements out of order because of insertion or modification, then they can lack proper indentation. The Smart Indent feature can quickly adjust code level to provide consistent indenting. Use find and replace. You will change a variable name, then use the editor find and replace feature. Do not expect that you will always be successful in making changes by just scanning the code. It is difficult to manually find all instances of the old name and spell the new name correctly. Similarly, you can use the search across files feature to find occurrences of the name to change in multiple files. Pay attention to M-Lint. The MATLAB product does not include a code checking tool that enforces coding or style standards. It does provide M-Lint, an edited tool that is primarily intended to point out coding errors. M-Lint also provides some warning messages that relate to style standards and best practices. Read the M-Lint error and warning messages as you write. Catch errors and poor message usage quickly and improve the code. Some of the warning messages can actually reveal errors. The message value assigned here to a variable read1 might be unused, can be caused by an inconsistently spelled variable name. Use consistent preference setting. Establish standard editor settings for tab and indent size, right and text assignment line and comment formatting. If you develop in a group, then try to agree on these settings so that you can more easily scan each other's code. Use the debugger effectively. Many users use MATLAB or to debugging rely on basic practices such as semicolon removal or simple functions such as display or sprintf. This strategy can be effective, but using debugger is often more efficient. You should change one of the default debugger settings to make better use of editor integration. Turn on always stop if you have error when debugging functions. With this menu selection, the editor opens the file when an error occurs, which cursor goes to the problem site. There are two features of debugger operation that may be unexpected, which stacks up debug conditions, so you may have to exit the debug mode or continue several times to return to non-debug mode. Also, the exit debug mode selection on a command sometimes turns out to always stop the error setting. Use the TODO FIXME report. When you cannot resolve an issue as you write, insert TODO or FIXME comments. These comments are gathered by the TODO FIXME directory report, which makes it easy to find the files and areas that you have identified for you. Most developers do not make a decision between TODO and FIXME. They simply use TODO. Make the format of these commands consistent across a project. For example, to revise the fraction is to %. Use the profiler. Do not rewrite code just for speed unless you have to. If you do need faster option, then be sure that you are changing the code that will make the most difference. The slow parts of your code may not be where you expect. Use the profiler to find bottlenecks in execution speed, and in some cases, suggestions for speed improvement. You can also use the profiler to access test coverage of the code lines. Use the dependency report. When assembling a toolbox or preparing for a case, run the dependency report to verify that required child functions are included. This report can also reveal any unintended dependencies of one function on others, especially dependence on functions that you do not intend to release. Publish during development. Use the public feature to view commands in a form that is more readable than the plain text in the editor window. This will make it easier to keep the code and commands consistent. It will also help you to determine the right format for the edit commands and for commands within the code body. Find a desktop layout that works for you. Reduce the distraction of window-focused changes by arranging your most used windows in MATLAB desktop. Many programmers find that the most useful desktop is the editor, the command window, the workspace browser, and the current folder window. If you write code in the editor and the use version control, the command history window is not important enough for the screen space that would require. Thank you. Thus, we have seen MATLAB coding guidelines. This is a very exhaustive coding guideline that's provided, and this can also be used for other programming languages if you follow it meticulously. And it's always a good practice to understand these coding guidelines, because these coding guidelines will become the basis for coding guidelines in the programming languages come across this one. And coding guidelines are very, very important, especially in embedded system development, as we have to do a lot of optimization of both time and memory in embedded system, and also for concepts like memory leak and all. So guidelines will definitely be very useful for you to achieve those